Hello, everyone, and welcome to episode 63 of Nutanix Weekly. I'm your host, Andy Whiteside. It's December 12th, 2022, and I've got a big crew of smart guys. Let me get them introduced here real quick. Harvey Green, my co-host from probably day one. Were you on day one, Harvey? I can't remember.
I feel like I was, but who knows?
Has it been that painful, really?
Yeah.
So, Harvey, this is your first December actually running a business, running the XenTegra Gov business.
Yes.
You know it's getting ready to get crazy, right?
Yes, 100%.
Good thing, though.
It has already done that.
I don't mean to scare you, but that means you're making money as long as the people pay their bills.
Yes, that is correct.
It's always the caveat.
That is always important.
It's kind of the way most businesses run, I think, right?
Well, yeah, it is. I've been listening to a book called Dot Bomb about a retailer from back in the 2000s. You guys may Value America. I didn't remember it. I do now that I listened to the book. But it reminds me how many companies out there run with the idea of just creating revenue because they're trying to sell themselves off as quick as they can. And and when you have to pay your own bills, that's a different world.
Yeah, I think you're either fundamentally in that, customers pay their bills model, or I guess you're running a debt collection agency. Those are kind of your two choices.
Well, 100%. That's XenTegra does a lot of that. We track down a lot of payments.
Yes.
Which I think ultimately all businesses do unless you pay up front or whatever. Philip Sellers, how's it going?
Good. How are you?
Good. So you are coming from the customer side, the VMware customer, specifically the Nutanix piece is something. Have you always looked at it like longingly from afar, or is this, really your first foray into the Nutanix world?
So I spent a day with Jirah at the Durham headquarters last month, and he made me a believer. Yes, I did mispronounce that. It's really interesting coming from a VMware background and looking at where Nutanix is at today. I knew it when it was SimpliVity versus Nutanix, the hyperconverged wars back before there was vSAN, all of that kind of thing. So I followed the company for a long time, and I'm really impressed with the ecosystem and the services that they enable. So I would say what I see about it today is it's really a platform play, and that's the investment for a customer, is that you're investing in a platform that's going to allow you to deliver your IT services that you need. And that's it's a cool value prop when you start going out and talking to customers about where Nutanix is at today.
Yeah. Yep. On-prem, colo, in the cloud, doesn't matter.
Platform. On your terms, where you want it.
Right, at any point in time.
Jirah Cox, happy to have you on the team, Phil.
You've been around for quite a while as well. You're still coming back, so must be having a little bit of fun.
Yeah, man. No, it's a blast. You guys put out the only Nutanix flavored partner podcast that I'm recording today.
Only one this week. Only one this month, I hope.
Yeah,
we appreciate you having you on here. You really do validate these conversations and get a lot of really good feedback from it.
Thank you, man. It's fun to do.
Ben Rogers, Ben, you've been a customer, been a friend of ours in multiple fronts. Is doing this podcast what you thought it would be?
It's been very interesting. When I did the Citrix podcast, I had 25 years of Citrix under my belt, so I was very confident in wherever we went. This is a little bit different of a ball game. And so there's been a couple of times I've showed up, learned on the fly. What I try to do is put it in a customer's perspective and either ask questions that I think customers would want to know answers to, but might be afraid to ask, or lean on our friend, the ninja Jirah here, and, try to get the scoop from him as I got him on the line, because being around him is definitely a great resource. And so, has it been what I thought? I don't know if I knew what to think about it, but man, I'm enjoying myself. And I always get, every time I publish this podcast, I always get positive feedback from Nutanix as an organization, and also customers of Nutanix that are out there that say they learned X, Y, and Z from listening to us.
Ben's too polite to go like, man, I thought there was a lot more preparation as a listener.
Well, he, like you said, he did the Citrix ones with us, so he saw the winging it model that still produces fruit. All right. So our blog for the
Let's
day.
let's digress on that for 1 second. For those of you that are listening to this, Andy's philosophy on these podcasts is you learn the subject as you log in to the podcast. So all of us have about 2 minutes to digest what we're going to talk about in expert format. So for all of you that are listening, just kind of understand when we sit at the table what we're dealing with on this.
Yes, but like in this case, the blog is the title of it's Honey, I Shrunk my cluster multiple nodes down in RF2 by what looks like Jeroen Tielen would be the name. Anybody want to try to repronounce that last name?
I would guess Tielen.
That's
just a guess.
That's what I would guess, Tielen. Yes.
I don't know where I got the TH. There was no TH. I made that up. Tielen. That makes total sense. But Jirah, you brought this blog, which thankfully you bring a lot of these, prepared to talk about them. What's the gist of what happened here and why he wrote this?
Yeah, so I love this post from Jeroen. It's on our community blog, by the way, where anybody can join as a member of the community. And if you've got something you want to say, for sure, it's a great platform for it. Jeroen posted this write-up from conversations he's had before of, hey, if I'm running, in this case, an example of 7 nodes with RF2, right, which is our structure for maintaining a data protection SLA of writing all data twice within a cluster. So that cluster, we say that it can lose one anything, right, a disk or a node. What happens if it loses 2, right? And what happens in that case? So great question, great exploration here. It's a real world customer facing question that we get a lot, actually, right? Is like so we plan for this much failure, but what if we get more failure than that?
So when he says in this second paragraph, we always, when we have larger clusters, we always recommend RF3. Is that just because more is better if you have the space?
Yeah, and I've seen some of the stats. It comes down to, like anything, right? If you ran even let's think just hypervisor only. If you're thinking about compute availability, well, gee, if I run a 10 node cluster or a 100 node cluster, at some point I want to size beyond just n+1, right? Like I wouldn't run a 99 node compute cluster of any hypervisor with only n+1 availability, because my odds as a practitioner, as the admin, having more than one availability zone, right? A blast radius, call it a single node, a compute factor, down at any one time, those odds increase astronomically beyond a certain kind of threshold. It always depends, but usually, let me fairly represent a lot of viewpoints here. Most SEs would tell you by at least the time you're hitting like node 24 in a cluster, we're probably at a threshold where we want to be designing for what we call RF3, right? Of all data written 3 times within a cluster versus all data written twice in a cluster. Because my odds of having one node fail and then another node fail after that, or maybe I'm doing maintenance and I have one node down and then another node chooses that time to purple screen or whatever it is, increase at that size.
Yeah, that's kind of my wife's logic. I've got 4 cars, most of them older, and chances are the more older cars I get, the more chances one of them's gonna be broken down.
Sure. Yeah. Fantastic analogy, right? I mean, I always say hardware gonna hardware. So
It's gonna do what it's gonna do.
True story.
All right. So he gives us a couple screenshots of his environment. The first one is redundancy factor readiness with a category of 2. The options, if I had to drop down ability here, would be 2 and 3. Are there any other options?
Basically, that's true for 99.99, a lot of 9s here. Most workloads, it's going to be RF2 and RF3. For a very small amount of workloads where you're doing in-app redundancy, right? In-app availability. I'm thinking of like Splunk. I'm thinking of Hadoop. I'm thinking of a couple of other workloads where the application's already going to split that, right, and store it 2 places. Then, of course, you can do RF1, understanding that when you're running RF1, if something goes bump and like a disk fails or whatever, it gets yanked, then you told us you already have availability at the application level elsewhere, right? So we don't rebuild that data. So, but yeah, for the most part, for common virtualization use cases, it's going to be RF2 and RF3.
I have to tell a little joke of myself. For the longest time, I said RF stood for write frequency, and then somebody pointed out that write starts with a W, and I was like, oh, crap.
So Andy, I think there's one thing that's worth mentioning here, and Philip kind of hinted to it when he gave his introduction. This is really what creates the platform of Nutanix, our ability to do this RF factor. not only is it protecting us from a data protection standpoint, but this also comes into play with how quickly will the cluster recover. If we've got that data spread peanut butter wise across these nodes, if a node fails, another node can take over really quick because it's got the data on it. Also, we talk a lot about VDI in your podcast, and this is also what makes our VDI load, the data locale. Even though we're replicating the data off, we're still keeping that workload local on the node that the data is there. And again, if that node was to fail, we have the metadata to know where to pick it up. Where do we need to go next to get that? So again, going back to Philip's, his mention of this is a platform. This is at the heart of this platform. And this really what makes Nutanix sing when it comes to things like performance, replication, disaster recovery. These are all the things we hinge on this idea of redundancy factor.
Totally. We live and die by it. Andy, I was going to say, all five of us here, right? As technologists in the Carolinas, we're already fighting uphill battle, right? Thank you for not highlighting our bad spelling on top of that, right?
You must know where I went to elementary school. So
yeah, I said all five of us here, right? I cast a wide net.
So, Philip, you want to tell us what this managed VM high availability piece means? Probably looking at me like, you're not sharing the screen, you idiot. Yeah, this part.
So,
Go ahead, Philip.
Hey, go ahead, Jirah.
Oh, sure. So the checkbox you're showing on screen there is that HA reservation, right? So as the compute layer, right, as virtualization managing the virtual machines, right, you can run the high availability engine in basically two models. Out of the box, you're getting HA and you're getting best effort, right, where impacted VMs from like a hardware failure event will get restarted automatically on surviving nodes in the cluster. That is, of course, out of the box, you get best effort. And then with this checkbox, you can opt into, hey, go ahead and pre-reserve memory for me so I get guaranteed availability. My VMs already have a pre-reserved space for them to boot back up. Basically, you're moving from an N+0 VM memory model into N+1.
Yeah. Yeah, I jokingly brought that up to Philip because some of these things have been around for a little while or a while now in the Nutanix platform. But when I meet customers, they assume some of this stuff is only available in the VMware side of the solution.
Yeah, and I mean this is essentially the same as the VMware. So you've got a parity here. So HA, you put in the number of hosts to fail, toleration level in VMware, and it reserves that space very similarly, although it's a slightly different take, I guess, here from the Nutanix platform side.
Well, and Philip, that's something I would ask you, coming over from a pure VMware world where now you do both. Have you been surprised at how many these features that are available on the Acropolis side of things that maybe weren't available when you looked at it a while back, if ever?
Oh yeah. I mean, it's pretty incredible what's been done out on the platform and enabled on AHV. It's very comparable coming from a VMware background.
So
I usually say it's different, but it's different. There's not a checkbox for every checkbox you're used to seeing on a platform, but it's got everything you need.
So, Jirah, I'm going to walk through this and kind of let you go through what the customer had set up and give any insight. And then I'll let the guys just interrupt us and comment as needed. You want to hit here where he's talking about what the workload is?
Yeah. So Jeroen highlights that he's got 30 Windows VMs. They're running Windows 11, doing VDI with VTPM enabled. And of course, those VMs are spread across nodes in the cluster, right? So there's some VMs running on every node in the cluster, roughly, what would that be? 4.5 or so VMs per host on average. So nothing's maxed out on resources. He highlights that he's at like 25% CPU consumption, about 40% memory consumption.
Mm-hmm.
Did he tell
us how many VDI it was? Oh, 30. No?
Yep.
Yeah.
30 VMs. So then he puts on his Chaos Monkey hat and decides to go crash a node. So he logs into the hardware management out of band and, tells it, hey, power off server immediately, no warning. No notification to like the virtualization layer, the storage layer, management layer, none of that, right? So immediately it's like pulling the power cord, one node goes off. So then, of course, no surprise, what you expect, right? HA kicks in, VMs get restarted on surviving nodes in the cluster, right? So only the impacted VMs, of course, have to do anything, right? Other VMs just keep on running. So the remaining nodes power on the VMs in the cluster. The dashboard, right, Prism, we give a lot of pixels right there on the dashboard, just showing the administrator cluster state and what's going on, right? What operations are we performing? What are we recovering from? Or is everything totally just situation normal? So immediately it goes into a healing state. It alerts him that, hey, VMs are getting migrated or restarting in order to get back to a highly available state. And then, of course, storage rebuilds also occur, right? So when you lose the hardware instance, right, the hypervisor instance, you're going to lose some slice of all your user VMs, your customer provisioned VMs, and then, of course, our virtual machine as well, right? Our CVM, our controller VM that we run one of on every node in the cluster. So that CVM goes down as well. It was hosting some portion of the data, right? Roughly, in this case, 1/7 of all the data stored in the cluster. And so the other 6 surviving CVMs are going to start that rebuild to pick up the slack from that failed node and therefore the failed CVM as well.
So Jirah, it didn't say, or did it, whether these were persistent or non-persistent VDIs?
Good question. It didn't say, and let me think if that matters. It really doesn't, right? Because if it's non-persistent, you're going to get back to that pristine image that was whatever your deep freeze state that gold master is. If it's persistent, then that's simply just a HA event, power off, clean boot on another node.
Just may take a little longer to grab all the bits from a non-persistent because there's likely more of those. So the healing process will maybe take a little longer.
Well, possibly, but to chase the tangent, if you're using non-persistent with us, probably doing, well, if you're doing PVS, right, then whatever network is going to network. If you're doing MCS, right, then you're doing differencing disks, right, against a Goldmaster snapshot. And we actually, under the covers, will do what we call a shadow clone, where whenever we detect that there's one vDisk in the cluster that's doing extra duty, right, it's one vDisk powering multiple VMs, we actually will cache that VM locally on every node in the cluster so that all those reads go back to local flash. We'll actually intercept that read operation from the hypervisor down to the vDisk and redirect it locally, even if the authoritative copy was elsewhere in the cluster. So we're shortening that read path. So you really won't feel that, I don't think.
So Harvey, am I not right to say that if you were doing non-persistent and you were using MCS or dare I say PVS, this checkbox where you enabled the hardware reservation, this probably doesn't happen because you got to pull the machines to cover this.
Yeah, you don't have to have that extra reservation because you do have a pool, and it doesn't matter if you lose them. If you just restart more of them, the user might lose their session for a minute, but then they're able to just restart another one.
Yeah, there's going to
Andy, you're saying a model where you're doing like one to many, right? You're doing lots of users per VM instance, not a one-to-one.
It could be one-to-one. It's
still
just
be
a
one-to-one.
pool of machines that are always running. So let's say he had 30, and truth is he had 22 users, or maybe he had 30 users. He would probably have 35 to 40 up and running. So he would have probably lost, some of the users would have come back in and it would have had more machines. The hypervisor, not the hypervisor, but the control plane would have recognized, hey, I'm supposed to have 10 machines running and waiting. Something happened. I'm down to none or 5 or whatever. I need to turn a bunch on or whatever's still up. So chances are a good consultant would never check this box unless it was persistent, but who knows? I don't know what the situation is. Anyway, all right. So the rebuild, and then Jirah, maybe I'm here. Am I here where it says data resiliency status or no?
Yeah, so the rebuild continues, and it shows. So immediately it shows, my cluster, which is built to lose one of anything at once, whether that's a disk or a node or whatever. So on the dashboard right there, we're going to show fault tolerance is 0, right? We've got a little red flag next to it. You can click on it, right, and it even gives you the detailed view of like what's currently rebuilding, and the Nutanix cluster, right, and really what the CVM is doing for you all day, every day. It's not one giant monolithic application, right, like running CVM or running AOS. it's got a whole bunch of microservices within the cluster that all work together, right? That all create the cluster or the ring topology. Each one can like self-elect the different leaders and follower states. So it'll show you what part in this screenshot here. It's showing the Cassandra ring itself, the metadata partition, right, which is where we store our data about customer data in the cluster. That's the layer that's rebuilding, in this case, to back to resiliency, back to health, to where it can lose another one anything, right, a member in that ring.
So it's getting back to that RF2 stage where it's got you truly covered.
You can think of it as getting back to RF2 across a number of measures, right? RF2 for user data, RF2 for Nutanix data about the cluster itself.
Mm-hmm. And Jirah, what happens if there's not enough available space? Or I guess it would have told you that before this happened.
So, I mean, that's part of the planning, right? Is we never want any customer to be in a place where they couldn't lose their defined availability threshold, right? Like an RF2 cluster, right? You can lose a one anything, which includes a node. We don't want you to be within a node's worth of filling up the cluster, right? If you do, then yeah, totally, the cluster's going to fill up. You're going to have a bad day. What it really does is if you really just fill it up and you ran out of space, it's going to go into a read-only state to protect itself and protect your data, to say, I'm going to not disallow any new writes because we're just plumb full. Call support, we need to get this fixed, or call call Ben, call Harvey, right? Call Phil, we need to get you more space in here, right? So, bigger disks, another node, whatever it takes to establish health there in the cluster. Often it can be like delete some old snapshots if you wanted to, but yeah, if you run out of space forever, it's gonna go into a read-only state.
Yeah, let me pause here. Ben, Harvey, Philip, any questions, comments, takeaways?
No, I mean, I think that this is definitely describing where you'll be, and you just call Phil and he'll show up with all kinds of drives in his back pocket, and he can just switch them out for you.
you just run on down to the Best Buy and chuck some drives.
If it was just that easy. Well, I mean, one of the things we have to point out is before you got even into that state, the cluster would be screaming bloody murder. It would be going, hey, I can't run RF2. I'm not able to get to this compliance state. Need to have more memory. We have capacity planning in the cluster. So even though I know we're kind of in the lab and we're doing this and we want to see the results, I don't want any of our customers to think that, oh, there's no warning that this is coming down. These boxes will scream if these things get where they're in an unhealthy state. Totally right, Ben. Yeah, the cluster itself, we've taught it lots of tricks over the years. It'll email you. It can send out SNMP alerts. It can open up ServiceNow tickets if you allow that. Lots of fun tricks it's got to alert you. Hey, we are entering a non-resilient threshold, right, of the cluster state here. If you allow the phone home telemetry, right, we call it Pulse, right, so it can phone home with how healthy the cluster is running. It can ping your account team, right. They'll reach out. It can. There's a new trick that clusters learned last year, actually, where you can say, like in this case, let's say you've got a 7-node cluster, so therefore you shouldn't write more than 6 nodes worth of data. You can basically tell it, only show me 6 nodes worth of data, and don't even pretend that the 7th node exists, right? That is 100% is the 6-node line. So you can have it redraw all the graphs to say, this is what full looks like, this is what, therefore healthy is somewhere to the left of that. Don't make me track, am I over or under my 6-node threshold?
Right. So Jirah, this next section says after 30 minutes, CVM not reachable for 30 minutes, the node is being detached. In other words, it says, hey, I'm going to completely remove this guy from my story.
Yep. So this is one I really like a lot. So we've already begun the process. We've already at this point probably close to completing the process of rehealing from the failure state. What I love about Nutanix and the cluster design in general is it's self-healing. So we don't stay in a broken 7-node state for very long. We transition to a healthy 6-node state. 6 nodes becomes the new normal. That's all the nodes we have in the cluster and all the nodes we know about, right? So we don't stay in sort of like a degraded state. We eject the 7th node that's failed from the metadata ring, right? From our knowledge of what nodes exist in the cluster, for a lot of reasons, right? One, like we forget about it. There's some things we can clean up. We're not waiting for him to come back online. Another one, right? Let's say that node is down for a week. In a week, when it comes up, it has almost no useful data. So we don't want to treat it like it's, a prodigal node returned home, right? We'll just treat it like it's a new node and resync data over to it rather than differencing like, oh, what's new, what's changed, what's not changed. We'll just cut bait. And then if it comes back, great. We will accept it back into the cluster as a fresh node, taking that node 7 spot versus having to worry about differencing what data has changed or what hasn't.
Mm-hmm. That allows.
So we always heal down to a healthy state. We don't stay in a degraded state whenever we can help it.
Yeah, that allows you to sleep at night, not guessing what could be happening when you're not there to watch it. Guys, any comments on that?
Well, for me personally, this would definitely give me peace of mind because I've left the office several times where one drive that, you had a RAID 5 and one drive dropped out. And while you're getting the drive shipped back to you, those couple of hours, you're just praying to the IT gods that don't let anything go wrong. So for me to know that my technology would self-heal itself and assume that, the unit's bad, we're going to go ahead and get it out of the mix and we're going to continue to run in a healthy state. And you want to bring that unit back in, great, but we're going to treat that as a new unit. That's awesome, man. That definitely gives a good level of comfort that you don't have to, sit on pins and needles while things are being shipped to you or procured or any of those things that we're all used to dealing with.
Yeah. So Jeroen takes a step further, I believe, and now he's ready to at least know that he can take down another node and still be up and going.
Yep. So the process here actually remains the same. So you could actually keep on crashing a node, right? As long as you're going to allow, you can crash one node at a time, as long as you are allowing for that reheal to complete in between each node failure. So you could go from 7 to 6, 6 to 5, 5 to 4, 4 down to 3. And he actually talks about, what if you keep on going until you only have 2 nodes left? 2 nodes, right? At that point, we do under the covers, right? We have a metadata ring that is 3 nodes at a minimum size for RF2. But that's about as failed as you can get. Is you could have a 3-node cluster that then shucks one more node and is down to running on 2 nodes out of 3, like 2 legs out of 3 on the stool are there. That one won't reheal because you can't shrink down to a 2-node healthy cluster from a larger like 7-node cluster. 3 nodes is the minimum there. So once you've hit that 3-node threshold and you lose one more node, you can definitely hit RF2 for customer data, right? All your data written twice. In that case, it's fully mirrored, right? Everything's on node 1 and node 2, and node 3 is down out of sync. And at that point, if you lost one more node, well, then totally, you have no cluster left, right? You're down to 1 node out of 7. That's a non-survivable situation for the data. Your data is safe, but it's not going to run, not going to be operable, not going to be an online state for the cluster. And at that point, you do have to go get you some spare parts and bring at least one more node back online from your 1 node out of 7 state.
And Jirah, was this all doable because of, the magic of Nutanix plus the fact that he was running at such a low capacity to begin with?
Totally. So that's the real limit that most customers will hit first, right? Unless you are only using what simple math would tell us 1/7 of your storage capacity, you'll hit that first. Of let's say you're using 3 nodes worth of storage, then as soon as you have to rebuild onto fewer than 3 nodes, if the data doesn't fit, we're going to call that cluster full. It's going to go into a read-only state, and at that point, you've got to certainly lay hands on the hardware that's failed and bring that back online.
Yeah. Okay.
But yeah, you can fail nodes down to I call it like the water level of the cluster, right? If the cluster is a certain bucket, you can lose the top of the bucket, another slice of the bucket. You can keep on losing down until however full it is. And once you hit that threshold, then that's going to fill it up, and we'll go read only on that state.
And then the bringing this back online, it's just a matter of adding a node as they become healthy, and you want to reintroduce them. They come in as a foreign object that looks like, do they?
Totally, yeah. So there's one click on Prism there to say, like admit this node back into the cluster. If you're unsure about it, right? Like we sort of have a bit of as a software layer, we have a little bit of I think a wise and somewhat healthy mistrust of hardware health. So if that node's been flapping, it's been up and down, it's caused up enough heartburn that we ejected it from the ring, we're going to make you tell us, trust that node again, rather than do that sort of fully proactively, right? Maybe you're testing out some, flaky DIMMs, right? Or got some weird power going on in a cabinet in the data center. We'll let you tell us when that storm's passed, and then we'll admit that node back into the ring.
Mhm. So
There's some things we can't programmatically determine as software only.
So to a large degree, it's aware of that node and aware that it might come online, but it's completely mitigated it for now until you tell it, hey, I'm ready for you to reconsider bringing this guy back in.
Yeah, that's fair.
Okay. Philip, I'll go to you first. Any additional questions, comments, thoughts, things you'd like to add?
Yeah, I wanted to ask a little bit about exposure time. So, we've got this 30-minute timeout with the CVM where it gets ejected out of the metadata ring. So
yep,
you're really kind of sitting in an exposure time or exposed state for that 30 minutes or 30 minutes plus however long it takes to continue the rebuild, right?
It's a fantastic question, actually. Believe it or not, you don't. So as soon as you fail the node at the very next second, we're actually starting the customer data rebuild immediately. And every new write as well. So if a VM generates new data onto, like, let's say at the beginning, the 6 surviving nodes in the cluster, we're immediately honoring that write onto 2 different nodes, right? Maybe it was initially going to be targeted to node 1 and node 7 for the 2 replica copies, but now it'll be node 1 and node 6 or node 1 and node 5 or whatever it is. So we never accept a write as the platform. We never accept a write from a VM that we can't honor according to the replica factor, right? RF2 or RF3. So every data is immediately predicted that way for new data, and we immediately begin the rebuild of customer data as well, again, immediately. So actually what it is like, let's just say hypothetical for this crafted scenario, new writes are immediately protected according to the replica factor, and let's say the rebuild finishes in 15 minutes. The other 15 minutes is simply our confidence in the node itself before we eject it from the metadata ring. But that's not really user facing. It doesn't expose risk or cause exposure to your point, Philip. Great question. Fantastic question.
And that makes a ton of sense too, because as long as the rebuild is in place, then all your bits are protected. Yeah.
So there's parts of this that are totally inside baseball under the covers, under the hood, I should say, that we're being super transparent about what happens. And this is all in the Nutanix Bible as well, right? In terms of like what layers of data power the system and contribute to availability. But yeah, it's always been our operating thesis is, we have to be absolutely paranoid about customer data integrity, right? Otherwise, we're just useless as a platform, right? No one should trust us. So that's always been job one, is be a good steward of customer data. And that includes immediate rebuilds with no delay timers until we start the rebuild. We almost never, our view of the world is we never assume the hardware is going to come back, right? So we'll never delay a rebuild, hoping it will, trying to make our life easier. We'll take the harder path of start the rebuild now. And worst case, if that node does come back because it was just a transient power failure or a reboot, well, then worst case, we've overprotected some data and we can do that garbage cleanup, right? But we'll never let the customer run exposed, hoping and praying that hardware comes back when it might not.
Yeah. The other thing, and just to reiterate what you said, you've got this concept of the local cache in every node, and with VDI, it's one of the things that really makes it a great platform for running VDI is having that local copy on every single one of your nodes. So especially the non-persistent desktops, they're right there. It's never going to be faster than that, right? As Harvey says, you're never going to get food faster than in your own kitchen. So it's one of those great platform trade-offs. And you said it earlier, but I just wanted to reiterate, re-emphasize it, because it is one of the great use cases and why we like to do VDI on Nutanix is architecturally there's things there that help us.
Yeah, there's other things there that we've wanted forever. It just took Nutanix showing up to make it to where that was handled at a sub under the surface layer, so we could get on with brokering connections and enabling user experience.
You know what the best thing
100%.
about AHV is, don't you?
Best thing about HV, well, one of it's the cost under the inclusion of it. But no, what are you highlighting?
That's where I was going, man. Is that this is included with your AOS licensing? So where customers, let's forget all about the Broadcom and all that. we're going into, a little bit of a recession. Times are going to get a little tight. A lot of customers are looking at this as a way, could I get my budget a little skinnier and utilize something that I already own versus trying to reinvent the wheel with a secondary product?
Yeah, I totally get it. I totally agree. I mean, in the beginning, that was an argument that was true, but not a no-brainer. But as Philip pointed out a while ago, this thing that you guys at Nutanix have created, that is this cost-effective platform that now has all these additional services that's been bolted onto it. It really expanded that story.
It's not free. Now, nobody gets it for free, but it is included in your AOS licensing.
Right.
Totally. Yeah, plenty of opportunity there to simplify. I mean, zooming out for a second, KVM is one of the most widely deployed hypervisors in the world, right? The real trick we taught it here, in addition to speaking, CVMs for high-speed local storage, is manageability, right? Like, brought it into the family, right? You manage it with Prism. There's really no, if you already know how to run Nutanix, then managing AHV is kind of a non-issue, right? You run it like any other Nutanix cluster. So simplicity included.
Yeah, it's funny. Andy, you asked about the enabling HA reservation checkbox. There's a lot here as I've explored the Nutanix platform that reminds me of the early days of VMware, where they made clustering easy. You just went in and checked a box and now you had a cluster. And I remember doing Windows cluster builds that took 2 weeks to set up and configure and get all the bugs worked out prior to that. There's a lot of that exists in the platform too. Simplicity. Nutanix is doing a good job of delivering something complex under the covers in a simplistic way, operating it in a simplistic way. Those are things I think that resonate with technologists when they get to see what's being delivered to them. I've looked at other hypervisors, one from a large software company that may write operating systems, and it's clunky. It takes some extra steps. It's that old school clustering that from Windows. It's the same on Hyper-V, and there's something to be said about the simplistic message and delivery that Nutanix is doing here.
Well, I think one of the other benefits Nutanix has is it was born with vSAN hyperconverged processes and concepts and constructs, and from day one, that wasn't something that had to find its way into the solution. It was born that way, and sometimes it's just helpful to be born at a time when the future is there versus having to adapt to it.
Yeah, that's pretty fair. I mean, the point I like to make that it was taught to me years ago is like, any system of sufficient ability to run and solve business problems, there's complexity in that, right? It's just a matter of, it's a design question of, do we ask users to bear that complexity, or do we bear that complexity so that they get a simplified experience, right? There's complexity that is abstracted and going on under the hood. I heard one time that we evaluate any given VM right on 7 or 12 different metrics to determine where it's going to land, right? So there's plenty of decisions being made under the hood, but we just don't ask users to wade into the thick of that and make those for us, right? If we can abstract something, we will.
Right. Well, guys, we're more or less out of time. This has been a good conversation. Ben, any additional thoughts, comments?
No, I kind of go back to what Philip said at the beginning of the podcast. Man, this is a platform. It's not just a hyper-converged system anymore. And all the other product sets that we have, kind of hinge off of this idea of, spreading data across the cluster, data resiliency, all these things. So if you guys want to learn more, reach out to us. It's an exciting time to be at Nutanix. We're taking this technology to cloud now. That's opening up some doors for us. So really good time to be employed for Nutanix, really good time to be running Nutanix. And I look forward to what the future brings for us.
Harvey, what did we miss? You want to cover?
Well, since you time stamped and date stamped the episode at the start, I'll just remind everybody that this week is a third Friday week. So we're doing our workshop on Friday from 11 to 2. This week is Nutanix database service. So definitely jump on.
Formerly known
Right
as
on, man.
Era.
Formerly known as Era.
Man, that's a fun workshop, right? That's like that goes so far beyond this kind of like VM management, data rebuilding. It's like batteries included, right?
Yeah.
Like what can the platform really do for you and help streamline a lot of day two operations?
Yeah, I would laugh at one of my friends because he always tells me I come back with the phrase, "What else can you do?" every time he brings something up. This is one of those occasions where we just gone through, this entire podcast on some of the things that are underpinning the entire platform. And then it's like, well, what else can you do? Well, on Friday, you'll see more. And
Philip,
there's
anything
more
else?
where that came from.
No, I'll be on the same workshop with Harvey on Friday. We'd love to see you.
Yeah. Bill's going to do all the work this time. I'm just going to sit back and relax.
I have no doubt it'll go just fine. Jirah, one last chance. Anything? Jirah, anything else?
I shouldn't be blanking on that. Oh, well, we announced .next coming to Chicago, right? Definitely check out the site for that. Talk to your account teams. Tell them you want to get some passes. And we'd love to see you in Chicago as .next leaves the virtual world and goes back to the physical, or
That's right.
something like that. The analogy breaks down.
Well, and if you're looking for passes, if you renew with XenTegra, your existing licenses, we'll throw passes in. We're going to be giving away, I think, 20 passes. And I think we plan to give away. We plan to give away both the Broncos that we're giving away as far as Work Has No Boundaries at the event.
That's right.
There you go, man. I want to be a XenTegra customer.
Hey, you should be. You should be.
My fear is you wouldn't need us, but that's okay. All right, guys. Well, appreciate you guys joining and doing this with us, and we'll do it again in a week or two.
Sounds good.
All right. Thanks, everybody.